Hi guys, welcome to Programming Knowledge. This is Tanay Singhania and today we will talk about neural networks. What is a neural network? A neural network is a series of algorithms that endeavors to recognize the underlying relationships in a set of data. So it tries to mimic the how our human brain works. So it can adapt to changing input, so the network generates the best possible result without needing the to redesign the output criteria. Okay, so we will give a certain input, it processes it and gives us an output. Okay, and if we give more input, it tries to adapt to the new input and tries to fit the data perfectly. Okay, now it is based on the biological neural network. So, like in a neuron in a body, uh, dendrites receive certain input, nucleus and axon processes it, and an axon terminal is fired up. So a certain axon terminal is fired up. So similarly, we have implemented in a software world. So we will get an input, it will get processed here, and certain will be fired up. So for an example, uh, let's say we want to classify between dogs and so we will give the input of images of dogs and cats. Okay, the hidden layer would process it, and say the output. This neuron is for cats. This is for dogs. So if the image is of a cat, then this will get fired up, and if the image is of a dog, this neuron will get fired up. So there are three layers in a network of mainly three types of layers, and in a neural network. First is your input layer, which each neuron basically is depicts a feature of the input data. So if we have three features, there are three. If we have 10 features, so 10 neurons. And another layer is hidden layer. Hidden layer basically processes it, uh, where the all magic happens. And another layer is an output layer where we get output, the classification. Uh, so, artificial neural network. So, we will try to see what is an artificial neural network. So, for example, we have three input features x1, x2, and x3. Send it to some function which calculates a score. Basically, score is summation of xi into wi. Wi is the weights. What is the importance of weights? So we calculate a weighted sum, and say in our network, x1 is a feature more important than x2. So w1 will be greater than w2. So to show the importance, basically, uh, we have a weighted sum. Next is the threshold function. We pass the score into a threshold function or an activation function. So this gives a value in a certain range which can be further used. So if we want to give an output, say for cats and dogs, the features are x1, x2, and x3. We calculated a score, and through a threshold function, it will give me 0 or 1. Say 0 for dogs and 1 for your cat. Okay, pretty simple here. Okay, next up is your threshold functions. Let us talk about uh, these. So we have various functions we can use: sigmoid function, step function, ReLU function. Okay, activation functions. So let us look into it. Sigmoid function. So if the score we calculated is a positive score, we get a value between 0.5 to 1. And if it is a negative, we get 0 to 0.5. Basically, sigmoid function we gives a value between 0 to 1. Okay, according to the input. The step function gives 0. If the score we calculated is 0, is negative, sorry, we get a 0, and if it is a positive score, we get 1. And ReLU function returns the same value if it is a positive value, and if it is a negative value, we get 0. Okay, pretty straightforward uh, functions. Okay, So, as we were talking about the neural network, so this is a single layer uh, network, I would say. Two layer network, we can say. Input layer is not considered as a layer. We consider the hidden layer and an output layer. Okay, so this is a two layer network. We can have as many hidden layers as we want. So we can have 10 hidden for a network. More the hidden layers, more the complex is the network. So say we have two hidden layers here, so we can see how complex the network is. So we have five input and seven, four, three, seven. Yeah, seven neurons in a network. So we would have 7 into 5, 35, 35, 35 weights which will manipulate themselves to get the optimum value for this layer. And 7 here, 7 here. For this neurons, we would get about 49 weights. So 49 weights would manipulate themselves again to get a better output. Same goes for this layer also. Okay, so as we increase the number of hidden layers, we get a deep neural network. This is somewhat an example of a deep neural network. You can see is a complex network. It is a bit scary, but nothing to worry about. Okay, so next up is TensorFlow and PyTorch. These are basically two libraries, array and matrix libraries. So neural network, the logic deduces itself. Okay, in a network, say here, yeah, we give an input and it gets processed by calculating the score and the functions, and we get an okay. So if the output is wrong by certain amount, so that would be considered as a loss, and the network would tune itself to reduce that loss, and we would minimize that loss. So it would work itself out, and to you do that we use TensorFlow or PyTorch. These are basically two libraries that uses array and matrices manipulation. So based on tensor is nothing but an array. Okay, uh, let me show you. uh, yeah, okay, it's working. Let me import torch. So this will import me PyTorch. You need to install it if by pip. Okay, so let me find torch dot tensor, given array here. So you can see it returns me a tensor. Okay, so we can use basic mathematics also. Oh, I'm sorry. Yeah, so it works perfectly fine. It is similar to NumPy array, but it is more powerful and hence used for neural networks. Okay. Uh, Next, I wanted to talk about balancing of data. Say we have a situation of online transaction where a bank decides if a transaction is uh, considered fraud or not fraud, basically good or not good. So we have around 100,000 transactions, and 1,000 of them are fraud transactions. And if we are given that data, we can say that 99,000 are a good transaction. And say a model says every transaction is a good transaction and passes every transaction, including the fraud one. Then we can get a 99.001 accuracy, which is a good accuracy, but completely fails the purpose of the model. It does not detect any fraud transaction. Okay, so that is the reason why we need a completely balanced type of a data where we have almost equal amount of fraud transaction as well as good transactions, so that the model can learn itself and give a better get a better learning of the relationships. Okay, that's all for this video. Okay, yeah.